All right, we're going to look at the vertex form again today. So just reminders, the vertex form looks like this. Standard form is this. And then our parent function is y equals x squared. Remember, f of x and y equals, they're the same. Your parent function, it goes to the origin and it's going upward. So its vertex is 0, 0. And it is opens upward. So it's that U-shaped parabola. So that's the important thing about the parent function. So what you're going to see is how different quadratic functions transform from the parent function to another form by looking at this. It's usually going to be written like this or like this. For the vertex form, the vertex here is HK. Whatever values are in the HK spot. So that's your vertex. So for whatever values with X, which is your H, this is your crazy X, so don't forget it does the opposite. So those are things that you're going to have to remember. The great thing is the vertex form is on your formula chart right here. And so all you would need to remember is HK is your vertex. And standard form is already written here too. All right, so with our y equals a x minus h squared plus k, we're going to talk about all the different transformations that we learned yesterday. So the a value is going to tell you whether it's a stretch or a compression, vertical stretch or compression. Compression. There you go. So it's a stretch, like if you do times 2, that means, remember with the bowl of the parabola, it's going to become 2 times taller. So it's going to be like a stretch. A compression is going to make it smaller, a smaller, not as deep bowl. And I'll show you some examples of that. So stretch is if the number is bigger than 1. So you don't look at the negative at all. You only look at the absolute value of that number, which is just the positive of that number. If it's bigger than 1, it's a stretch. A is greater than 1, it's a stretch. If A is less than 1, it's a compression. So this would be like 2, 3, 4, so on. This would be like 0.5 or 0.75. Those are the numbers that we're looking at whenever you see compression. If A is negative, then you have a reflection. So instead of it being a U, it's the upside down of a U. Upside down U, like that. So that's the number out front. And it also goes for this one too. Both A's, you can look at that. And then our H, that's going to determine the left and the right. And this one's the crazy X. It does the opposite. It's the number with the X in the parentheses. So it does the opposite of what you would think. So if this says X plus H, it's going to go left. If it says X minus H, it's going to go right. So it does the opposite of what you would expect. And then the last type of transformation is K. K determines an up or a down. So if on the equation it says plus K, then it's up that many units. If it's minus K, then it's down that many units. So we're going to use this to find all the different transformations. So you can have up to 4 different transformations. One would be stretch or compression. 2 would be reflection. 3 would be left or right. And 4 would be up or down. So those are all the different types. All right, so we're going to look at 2 examples. That's y equals 2x plus 1 squared minus 3. So here's our equation. So we're going to come up with all the different transformations. So we look at the first number that's out front of the x squared, or the x, so 2. So if you look back up here, 2 is the A. A is greater than 1, 2, 3, 4, so on. It's a vertical stretch. I'm going to point to it, put a little dot, and put vertical stretch. So it's going to get skinnier. So if it's a 2, 3, 4, it's a stretch. It's going to get skinnier. If it's a 0.5, 0.25, 1 half, anything that's smaller than 1, it's going to be a compression. Then let's look at H and K. I'm just putting H and K right beside them or underneath. So the H says X plus 1. So we look up here. H, if it says X plus an H, it means it's left. It's going the opposite of what you would think. It's going to go left that many units. 1. And then K says minus 3. So it's going to go down 3. And the last thing we're going to write is our vertex. Vertex is HK. But remember, H is our crazy X. So we do the opposite. So our vertex is HK, but whenever it's X plus 1, that's the opposite. So we do a negative 1, H, and then K is negative 3. So that's all the information I want on each of these examples. We're going to look at it though. So go to y equals in your calculator. Let's look at the graph. Put it in. Make sure you put -3, not -3. They are different. All right, you ready to hit graph? And we can have it at zoom 6. That's a standard one. Okay. So if you want to hit zoom 6, or remember how I taught y'all zoom 4 for the decimal? Hit zoom decimal. If you can see the vertex on that, that's great. If you can't, then you're going to have to go back to standard or zoom out. All right, hit trace. It automatically goes where? What point is that called? Yep, the y-intercept. So anytime you graph, as soon as you hit trace, it's always going to go to the y-intercept. Now go right, and let's find our vertex. See if that is true, what we found. Yep, -1, -3. Okay, also, was it a stretch? Does it look a little skinnier, a little taller? It's pulled. It's not compressed, and it's not the normal. Look. And then it's normally at the origin, but you go left 1 and down 3. So that works. Let's look at the table real quick. So hit second table, and I'm going to go to my vertex. -1, -3. And I want my table to show me how it's symmetrical. So I'm going to put the vertex in the middle right there. So move your table, go up or down to make your vertex right in the middle of your table. And so the way you know it's your vertex is if it's symmetrical on the y values above the vertex and below the vertex. You see how 3 is in the middle? -3 is in the middle? And you go -1, +5, 15. And if you go down, -1, +5, 15. So that's also a way to show your vertex. All right, so we're done on that one. Let's do number 2. Y equals negative parentheses x plus 8 squared plus 1. So the first thing we look at is A. It's a -1, right? Or just negative. But what is that negative going to do? Look back up here. Yep, it's going to be a reflection. So that's our first thing we would write. Since it's a 1, it doesn't change it to a stretch or compression because it's just at 1. So now we look at H and K. Write down H and K below those numbers. So the H is, it says +8, so it does the opposite. So if it's +8, then do the opposite of what you think. Inside the parentheses is left and right. So +8 is going to mean it's going to go left. So it's doing the opposite of what you would think. So left 8. And then the K is -3. K, negative, means going down. Down. Where's it up? It's +1, so it's up. Up 1. Sorry, I got confused for a sec. All right, last thing is the vertex. So it's HK. So H says +8. So you do the opposite. -8. And K is 1. All right, last thing, we're going to check our work. So go to calculator, type it in. I'm going to go to graph. So if you can't see it, you're going to have to change your zoom settings. So go to zoom, and I'm going to go to standard, number 6. I can see the majority of it. So we just want to check that it's a reflection. Yep, it's the opposite of the U. Did it go left from the origin, 8, and up 1? It looks like it. So just to be sure, we're going to hit trace. Look at the coordinate that it's at, 0, -63. So it's all the way down here at the y-intercept. Okay, so we can go right from that y-intercept point in order to come up here. Pull it down until you see your little cursor. There we go. So the vertex is supposed to be at -8, 1. So this doesn't give us exactly that point, but we can round it. -8, yeah, that would round to -8. 0.992, that would round to 1. So we're good. That's our vertex. The other thing you can check is the table. So go second, table, and I want you to move this so that -8, 1 is in the middle so you can see if it's symmetrical. -8, 1 right there in the middle. And it is. It's symmetrical. Okay, I'm going to pass out the papers for the matching assignment that y'all are going to get started today. All right, so let's look at this one. I want y'all to go ahead and write the vertex. We need the coordinates for the vertex. Whenever I was looking over y'all's benchmark, one of the questions was, is the vertex? What is the vertex? And people messed it up because of the coordinates. So we know that point where it changes direction is the vertex. So it's right here. So this is -1, 2, 3, 0. And from the vertex, what is the transformation? What's the translation? Like how was it moved? It would have been normally 0, 0 if it's y equals x squared. So what direction was it moved to get to that vertex -3, 0? What was it moved? Look at it. Look at my finger at the origin. It was moved left 3. That's the only translation or transformation that this one has. The way you know if it's a vertical stretch or compression, you look at these 3 points. See how it's just right there? You have one in the middle, and then you go over one, up one, over one, up one. This is what I'm going to call a regular bowl. So it did not stretch or compress. I do want to show you one that's not a regular bowl. Look at this one. See how this doesn't have it at the vertex and then right and up? This is stretched a little bit more. So this is a stretch. Look at the bowl. Whenever I say bowl, it's your first 3 points, the vertex and the two next points. So this is a regular, not a regular bowl, it's a stretch. If you want to put that on here, you can, just to help you remember what the difference is. All right, let's go ahead and write our equation here. So the A is going to be 1. It's going to stay the same. The only thing that's different is our H. So on our note, to go left 3, how is our equation going to have to be? Left means it's x plus h. So that's the only difference for our equation. So y equals, there is no a because we don't have a stretch or compression. It's not negative because it's not a reflection. So the only thing will be x, left means plus h, so plus 3 squared, with me? And then k would be if it's plus or minus or up or down, which it wasn't. So that's our equation. All it had was a left 3, which is crazy x. It's going to go the opposite. So now look for this in your little rectangles that we cut out. And it's right here. So on your rectangle, go ahead and put D1. Before you move on to the next one, though, I want you to go ahead and graph it and make sure that this graph is the same thing as that. So y equals. I'm going to clear out what's in there and put in what we think is correct. So x plus 3 squared. X plus 3 squared. Got it in? Now hit graph. Let's just make sure does it look the same? The only thing that's different is the window, like how it's zoomed in or out, but it's on the x-axis. If we hit trace, we could go and find our our vertex, which is -3. Remember that e to the -4, that means it's really, really close to 0 because you would move your decimal over and add a bunch of zeros. So that's right. All right, let's look at one that has all of the transformations. It's a reflection, it's a stretch or compression, and it translates left or right and up and down. Look for one that has all the different transformations. So it's reflective. So D15 is a reflection, but is it moved left or right? No. Yeah, 16. So that one has all the different transformations. So everybody go to D16. All right, so let's find our vertex first. What's the vertex? +1, 3. Okay. Let's see what else we need to come up with. It's a reflection. So go ahead and write that because it's opposite of the U. We have a reflection. And does it have the 3 points in a regular size bowl? Look at the 3 points. Are they in a regular size bowl? No. Is it a stretch or compression? Stretch, yeah. Vertical stretch. So that means your number, how much of a stretch is it? It's normally at over 1, 1. It's over 1, 2. So our A is actually going to be -2 because of the reflection. And then our last thing is, how was it translated? Which direction from the origin did it go to get here? Right? One. We have one more thing. And how did it get up here? Up 3. All right, so look at your answers that you're looking through, all of these. Oh, we haven't wrote the thing. Y equals, it's going to be, oh, let's write it down here. A x minus h squared plus k. That's going to help us. Okay, because it's a reflection, A is -2, parentheses, x. The h does the opposite. So instead of this being 1, it's going to be your crazy x minus 1 squared. And then k up 3. Now find it in your pile. And go ahead and label your 16. Oh, you can also graph it and look at it. Go ahead and put it into y equals. Put it into y equals. Look at your graph and make sure it does look like that. Hey, look at how I put it in. Look, we can just look at it together if you haven't typed it in. Make graph. Here's the origin. Here's my origin. Here's the vertex. Looks pretty good. You can always hit trace. Its y-intercept is at 1. You go right. There's your point. 1, 3. All right, we're going to continue working on this tomorrow.